Great. So as I said, I will start with this introduction, a few slides, to set the context of ESA Datalabs activity or initiative, which comprises several projects, which was initiated in 2017 as an idea, as a concept. So it took a while from idea inception until implementation. And today I'm going to present not only the current status, but also what is about to come in the next months regarding ESA Datalabs. So I'm going to show some, I'm going to provide access to a demo of the system in development. So let's keep our fingers crossed, because being the development environment, we might have some surprises. So what are the goals that we are trying to address with the ESA Datalabs initiative and related to open science? So what we have observed is that there's the need to innovate in the way we access data and the way we use data. And why? Because you can see now on the screen, the amount of data that is being currently generated is exceeding the trend is exceeding the past expectations and past measurements that we had. And what you can see on the screen on the left-hand side is the increase in the data rate generated by different ESA missions and the storage that these ESA missions are consuming in our scientific archives. And you can see that there will be quite a jump once we introduce Euclid into the picture, because there will be around 10 petabytes increase in terms of data in the archives, which is right now already in the order of 2 petabytes. And then but that's for an example from space science. And on the right-hand side, you can see an example from navigation science, just to provide examples from different domains. In this case, navigation signals coming from the different constellations of global navigation satellite systems like Galileo or GPS. And this is a use case and a project that is called GNSS Big Data, where we generate, or we aim at storing the raw intermediate frequency signal that is generated by the navigation satellites, which is currently discarded. We just, at the edge, at the receiver, receivers are generating a set of files, RAINX files that produce the relevant data for positioning, navigation, and timing, and the signal is discarded. But if you want to do interesting things with that signal, which are not directly related to the core business of navigation, like, for example, retrospective assessment of ionospheric effects, you have lost a lot of information. So in this project, we are aiming at recording, and we have special receivers that are recording the full signal. And this use case, for example, we generate like 8.3 terabytes of data per day per station, and for a network of around 120 stations, 1 petabyte of data per day. So coming back to the problem of data access and data sharing, we have realized, and it's obvious from many of the presentations that have been given today, that the past story where we were downloading the data to our computers or our data centers and we were exploiting the data there is not anymore an option, or it's not going to be an option. We need to get the computation to the data. And this is a paradigm that has been developing gradually over the last years, and that now is an accepted change of paradigm. So this was one of the motivations for ESA Datalabs. The other motivation is the data processing innovation needs that we have also observed. The traditional data processing pipelines that we have in the science operation centers that are receiving the payload data from the spacecraft and generating products are the typical examples. And these pipelines are getting more and more complicated, and the need to deliver these pipelines or implement these pipelines quickly is also a continuous request from our missions. But in addition to that, I have this special slide, we are getting to know a new type of pipelines that are also becoming very popular, which are the machine learning pipelines. And the objective of ESA Datalabs is to provide an environment to activate what is called as MLOps, the possibility to create a machine learning pipeline that is at the same time feeding with the results the machine learning models, so that you can improve your model for the next iteration of the reception of the data. What we can see here from kind of qualitative view of the different elements that are involved in the pipeline is that most of these elements are not directly related to machine learning code as such, which is just a part, but there are many surrounding elements that you need to take into account when you create this. So this is innovation in terms of pipelines. And then the last part of the innovation challenge that we are trying to address with ESA Datalabs is the collaborative innovation, which is clearly directly related to the open science initiative. And the need to share not just data, but also applications. So with ESA Datalabs, we want to offer the possibility to access the data. Traditionally, we've been doing this with our space archives, the European Space Data Center that is located here at ESA is providing access to the space science missions run by ESA, managed by ESA here. So we have already that infrastructure in place, enabling access to the data. And at the same time, we also want to offer the possibility for our scientists to provide data that can be shared with other scientists, or generate data that can be easily shared, accessed, maybe generating data from the data that we have in the archives. So that's kind of, again, the traditional, but at the same time, we have seen also in many presentations, there's the trait of the complementary trait of the applications and data analysis tools that we are using to generate products or to obtain information and discover facts in the data that we have. And we are also interested in sharing these applications and in sharing the data processing algorithms that we've been using to come up with a scientific paper, for example, so that we publish a paper where the community can actually come back to the source of the algorithm that was used and rerun and repeat the same results, reusing exactly the algorithms that were used. And one of the solutions that we have envisaged for that is the creation of an application store, the same way as you have the app stores from Google or from Apple, which are quite famous. There's a proliferation of app stores. The concept that we are using to agglutinate all this sharing and collaboration is pivoting around the concept of an application store. And now, just to finalize the context, well, what is ESA Datalabs? Well, on the ESA Datalabs, you can identify a platform which is made of 3 different elements. The core, which is the IT infrastructure that is run on top of Kubernetes clusters, Docker containers, Elasticsearch, infrastructure that is typically well known in the cloud computing world. And then on top of that infrastructure, what we have done is we have built the functionality I was mentioning before for data processing pipelines and the functionality for data collaboration and functionality for the App Store that I was mentioning before. And once you have this infrastructure, then what we want is also to be able to extend infrastructure beyond the boundaries of our organization so that we can leverage on cloud computing infrastructure that is not just ESA infrastructures, but Amazon Web Services or Azure or European platforms that are provided for computing, so that we can scale beyond the limits and boundaries of our organization in case the user wants to connect resources that are available in the other infrastructures. So that would be on the one side the platform, and on the other side we have the community. And for this we have had a collaboration of the ESA Science Data Center that I was saying before, and missions like JUICE, BP Colombo, and JWST that have been acting as the key stakeholders driving the implementation of the Datalabs initiative. And finally, as I was mentioning at the beginning, we have on one side the release of the private beta that was done in March 2022, which is what I'm going to show today. And just to let you know the plans, the roadmap is that we will provide public access to this infrastructure in Q3 2022. So now I'm going to switch to the real system. This is just in case we have a problem with the real system, and I'm going to share my screen with see. Can you see my screen now?
Yeah, we can see your screen.
So you can see datalabs.esa.int.
Yeah.
Okay. So now you are looking at the platform. If you go to datalabs.esa.int, you will be able to access to see what I see, right, what I'm showing right now on the screen. And as I was mentioning before, you will see in the banner that the public access to this platform is planned for Q3 2022. So yeah. So right now, what we have is what we call a private beta access that is mainly restricted to the missions, ESA missions and key stakeholders that have been granted to access to the system as private beta users. And this is what they can actually see. Just log in. You can see that we are running version 0.3.0 beta. And this is the environment for ESA Datalabs. So what we can see, the first thing that we can see on the screen is the Datalabs section, what we call the data volumes, file browser, and notifications and my user. I will go first through the Datalabs. In this section, what we see right now is a set of applications, Datalabs, that have been launched in the platform that I can access and run. Actually, these ones are already running. So it's a list of applications that I can execute and open, like Aladdin, Use. This is a demonstrator created by the Use mission and Sun Jupyter Labs. Where are these applications coming from? These applications are coming from a catalog of Datalabs that is available for me to instantiate just with one click. So clicking on the catalog, I can find the full list of applications that are available for me to execute in this environment, which will, for example, I can search TopCat, for example, is one of the applications. And if I'm interested in running TopCat, I can click here and say my TopCat and launch it. And if everything goes as it should go, in a few seconds, I will be running the TopCat instant, with it's running in our IT infrastructure here at ESAC, and you're accessing just with your web browser. As you know, TopCat is not a web-based application, it's a desktop-based application. So this means that it's not designed to run on a web browser. What we are doing in this case is we are launching a container that contains TopCat, at the same time is throwing or sending the image of that container through a kind of channel that arrives to the browser. Right now, I don't know whether this is the demo effect. It's taking far too long. So let's see. In the meantime, maybe while TopCat comes up, I can launch an existing one, which is Aladdin. It's taking far too long. Demo effect, I'm afraid. So I will go to Aladdin. Okay, so this is Aladdin. I launched Aladdin before, and it was one of the applications that I had run. And you can see Aladdin is the same example. It's a desktop-based application, which is now running on my web browser as a traditional desktop application. So I can go here and use Aladdin in the standard way. So it's, well, my screen is a little bit small, but you can see that this is Aladdin, and I can actually switch from one application to another. Or I can go back. I don't know why TopCat is still not launching. We have to see later. But I can move from Aladdin to other applications that I have launched, like this JWST. My colleague Marcos Lopez-Caniego will talk about the JWST example in a few minutes. And I can launch and go back to another application that I have launched before, like this one. This is a Jupyter lab-based application, and related to the reproducibility that I was mentioning before. The idea here is that I can provide this data lab in the repository of applications that we have here, so that a user with an account in ESA Datalabs can actually access the same notebook that was used in a given paper, for example. And I'm trying to see why TopCat is not launching. Still not there. So, okay. So this is what comes about different applications. And as you can see here, the dominant application is a Jupyter Lab-based application where we are making available the containers. Okay? So Let me see. I'm going to, maybe I reach the limit of applications that I have. So I'm going to delete this one. I'm going to delete this one that will be presented by Marcos later. And I'm going to go back to launch a new data lab, and I'm going to see, for example, this one. Yes, this test. So let's see whether this one is actually launching or whether there's a problem now launching. I hope there's not a problem launching data labs, otherwise the next demo, yeah, this one is launching. I don't know what, there must be something wrong with TopCat right now, because now you can see this one has turned to green and it should be activated now. Yeah. So this is typically the behavior of the system, except for the demo before for TopCat, where basically you go, launch, and then you always get, in the case of the Jupyter notebooks, you get something like this by default. So you get a folder data where you can find the data that we will see before, and you had what we call the workspace. This workspace is a private area of the user where the user can upload information as a kind of Dropbox or Google Drive. So you can upload information to your workspace so that it's available for you here to carry out your own development of notebooks. So you can test your notebooks here, and then we can create the data lab with the final notebook that you have been using and publish a data lab about that. So here, what you can see is a notebook that has been created by Gaia for a machine learning example. Okay, so we just launched this one, and this Gaia is in my workspace. So the my workspace is nothing else but this area here that you can see, where I can upload information. I can create even test data. I can create a new file, for example, my file create, okay, like hello, and even save, close my file. And if I go now to the ESDC test, and I go to my workspace, test, you can see my file here. Okay, so you can use this as a kind of Dropbox where you can upload data, and that Dropbox is attached to all the data labs that you launch, so that you can incorporate notebooks or whatever you want in your workspace. So this is about the workspaces. And then you have this folder, which is called data, that currently is empty. So the data folder is the link with the data sharing functionality I was explaining before. So you can go to the data volumes catalog and find there the different data volumes coming from the missions that we have in the archives. So you can see, for example, a catalog for Planck data, or JWST public data, or JWST CRDS data, which have been made available through this platform in order to allow the data labs to mount that data and make it available to the scientific notebooks that you have there. So if I go, for example, to this, there's this GSSC satellite, for example. If I go to the previous lab and I select from this drop-down list the GSSC satellite, the data volume with the terabytes of data stored in that area is made available here. So now the GNSS in space, for example, contains all the, in this case, this is a repository of data for different missions with a GNSS receiver on board, and then you have this. Later on in the demonstration, in the tutorial that is going to be provided by Marcos, you will have a real-life example for JWST run by Marcos. So you can see here how the data becomes available. You can see the workspace also becoming available to the data labs, and the possibility to run different data labs, except if it is a TopCat, which seems to be not running. But basically, you can run web-based, like Jupyter Labs, or non-web-based applications like Aladdin, TopCat, or whatever. I'm tempted to launch TopCat again, but okay. So this is about the current functionality that is available in ESA Datalabs. I will give a brief review of the functionality. You can see that look and feel is different because we have, this is the look and feel of the development environment, whereas this is the look and feel of the production environment. So this is still not integrated into the production environment, but this is the part related to the pipelines that I was mentioning before. So here we have the possibility to define scientific pipelines with a pipeline editor. And if I go to the pipeline editor, you can see an example. Marcos will go into the details of the pipeline for JWST. So I just give now a quick example of a simple pipeline, which is the Hello pipeline, just to demonstrate very quickly how the user interface looks like and how it works. Here you have a set of, you have the same way you have a catalog of different steps in a pipeline, and also you have pipelines, which are combinations of steps. So from this catalog, you can take different processing steps that can be dragged into the pipeline editor and connect the dots in order to create a new pipeline. Okay? So this is a Hello World pipeline, which basically the Figlet step takes as an input a file and a text, and takes this text and appends the text to the text file that is provided as an input. Okay? So if I go to the pipeline dashboard, you can see that I have run already this morning. I ran the Hello Pipeline example, and I could, after running, you could see this pipeline has 3 steps. The 3 of them were executed. There's a set of logs. This is the example, the parameters that I provided in the description of that step. There's the graph, and there's also the CWL code that is running behind the curtain when you execute a pipeline. Okay? So very quickly, I'm going to launch one like this one, just to this is, and then I provide the file input. So I have here Hello World input, select, which contains Hello World text, then pipeline. Okay, and then I select an output, which is the pipeline output. Okay. So basically here, in terms of collaboration, our users could select a shared area, a shared directory output, where they can generate outputs for a given pipeline. They can modify parameters, and they can generate different products based on different parameters and files. And these products could be generated into a shared output directory where other users can actually find the results of the execution. You can add a schedule so that this is run on a daily basis, on a monthly basis, on an hourly basis, notifications in terms of execution, and then you click on launch the pipeline. So you can see this was executed, and now this has been added to the queue for execution in the pipeline. Okay? And at some point, it enters into, it's there. So it's actually, you can see that it's executing step 1 of the pipeline. You can monitor the execution. Here, step 2, and now I will run step 3. So finish. Okay, so I close. And if you remember, I generated this in my pipeline output directory. It must be. This is the development environment now, playing tricks on me. This is just disconnected. Okay, so files somehow it disconnected from the file browser. Okay, so you will have to, Marcos, I don't know whether you will be able to run your demo on the pipeline environment later, because it looks like now it's a bit unstable. But in principle, the execution took place, and the file should have been generated in the directory, but now it looks like it's not able to. So maybe I destroy. It's launched later. So maybe we'll come back later. I can come back to this later, but just in order to make progress, I'm going to show the last part of the demo, which is the Datalabs application store, where basically what we have in this environment is the possibility to create Datalabs as a development environment. So this offers the possibility for me to develop data labs with a kind of wizard. And yeah, here, also connected to the possibility to create reproducible data analysis tools, you have the possibility to select basically a data lab container that is assigned a title, abstract version, and what I wanted to show to you here is, for example, the possibility to assign a creator ID and a patch and a DOI, so that your data lab can actually be referenced with a DOI in order to make it available through this platform in a publication. And therefore, with this, the data lab can be later on linked to the execution of a given paper. So let me see whether this is now working, whether it reconnected. Okay, let's see. The lab list is empty. Okay, maybe it's coming back. Connection reestablished. Yeah, I think it's coming back. Yeah. Okay. Okay. Okay, let's see. Now if I go to the pipeline output directory, you see the connection reestablished. Thank you. The final text that I was mentioning before, you see, hello world, this is Payman. So it has reconnected now, and you can see the output of the pipeline that I was mentioning before with these parameters that you could see. This is Payman with 3 exclamation marks, and this is what we have got in the output directory after the execution of the Payman. Okay, so there was a glitch in the connection to the data volume with the information of the file. It was established. This is one of the characteristics of this environment, is that if something falls apart or breaks, and the system itself has a self-healing mechanism that detects that there was, in this case, most probably there was a pod falling, and then the system itself detected that and relaunched the faulty container, regenerating the logic, and the data is always persistent, so there's no data loss. So, and the last step of my demo is, this is also going to a development environment, is something that we don't have in our production catalog of data labs, and is the possibility to launch a data lab which has, let me see, which has GPU support. In this case, this is a Jupyter lab which requires a GPU processor in order to execute the functionality. So this is inside our Kubernetes cluster. We have a GPU available to the Kubernetes cluster. And in case you want to develop logic for GPU, you can create a data lab specific for GPU processing, which will be allocated to a node with a GPU. And this is the GPU test. Launch it. So if everything goes fine, in a few seconds, we will instantiate a Jupyter lab with a notebook that contains logic for GPU computing. Yeah, it's now there. So again, I can go to the notebooks. You can see the same structure as usual. So there's data, there's the workspace, and then there's the notebooks. And here in the notebooks, you have an example. It's a very simple example, which returns the number of GPUs, which, for example, well, first I have to select the kernel for CUDA, which is the kernel for GPU-enabled notebooks. And basically, it will import TensorFlow library successfully, as you can see, and it returns basically the number of GPUs. In this case, there's only one, so assigns device 0, which is the only GPU that we have here. There are other examples here, like this one, select, which is, again, providing information like this is the typical command that returns information about the GPU that is assigned to the node. And then now here we list off the list of all devices. And finally, in this case, this is another text just to demonstrate that there's a GPU behind this. So, and basically, if you get true here, as the comment reads, if it's not, the value will return is really fast. So false. In this case, we can see that there's a GPU. So with one click, I have instantiated a data lab, which is contained in a Jupyter lab with a set of notebooks that have been created to demonstrate a specific algorithm on a GPU. And with this, I have covered all the different elements in the area of GPU computing, data labs, pipelines, and App Store. And I can now give the floor to my colleague, Marcos, who is going to present the specific examples applied to the JWST. So, Marcos.
Okay. So, thank you, Vicente. Let me try to share my screen. Let's see. I think you need to stop sharing.
I stopped already.
Oh, okay. Okay. Yeah,
Yeah.
Okay. Are you seeing my browser now? Just my browser or the full screen?
Just your browser.
Okay. Good. Okay. So now let me give you some examples more specific for the JWST project. Since Vicente already mentioned that since the beginning of when the development of ESA Datalabs platform started, JWST has been one of the use cases that has been there from the beginning. So we had the possibility so we were very lucky that we could learn from the process and also to start using it from the beginning for the commissioning of James Webb. And we have scientists from the team already working on the platform. Okay, so this is the main entrance point for ESA Datalabs that was shown by Vicente. So now let me jump directly into the James Webb use case. So just it was briefly mentioned by Vicente. So for James Webb, we have deployed multiple containers in Datalabs. That some of them are more general, like the one that I will be showing now. That is more intended for further exploitation of the JWST data once it becomes public. But we also created some other containers that for work that is being done at the moment. One of them is this JWST Miracle that contains some simulation software from the MIRI instrument on board James Webb. Then we also have another container with some also some analysis software for the NISPEC instrument. And then we have another James Webb area for additional work from the instrument team in Baltimore and at ISAC and at STEC. So now I will show you the example of the general James Webb area. So I already launched this, so it will load like really quickly. So when you enter in this area, what we want to give is the users of James Webb the possibility to analyze the data, and also the data that is available from the archives. In our case, since there is a JWST archive at ISAC intended more for focus more on the needs of the European astronomers, then we have an AstroQuery module that can be used to query our archive, and from which users will be able to download data in the future. So when you enter in this area and then you have access to this JWST NFS volume, when you go into this volume, what we offer to the users is first is since the calibration pipeline, the official calibration pipeline from James Webb comes pre-installed in this data lab. What we are offering here is the calibration files that are needed to execute that pipeline. So this is this is something of the order of 400 gigabytes that the user does not need to download when using this platform. And we also keep it up to date so that the users will have access to the latest version of the calibration software and also to the latest version of the calibration files at any given time. So in addition to this, we give some example notebooks. One of the notebooks that we give, I will show you in a minute, is an example of how to query our archive and how to do so, display some of the metadata in that in those queries, because as you know, the James Webb data is not yet public, so I will not be showing any James Webb data. But then at the same time, we are also providing access to example notebooks that have been developed by the Space Telescope Science Institute to analyze web data. So if I start with in this folder, there is this ESA Datalabs example Astro Query and PySky notebook, which is this one. So let me just go through it. It's not a long notebook. So here what we have is just an example of how we expect that users will use the Astro Query module to query the archive. Good things about these notebooks, and this has been discussed already, mentioned many times in this workshop, is that for the purpose of reproducibility, if you have a static notebook that is provided by the team, that is tested and that is versioned, that can be used to do some analysis. This is always great if you share it with somebody else that you want them to do the same analysis and come to the same conclusion. And also as I will show later, for the particular case of the GWST processing, the pipeline system that we will offer, it also contains a versioning system that will also allow users to have a very good control of which version of the software and of the pipeline was used to reprocess any data. And this can also be shared among users. So let me now just quickly go over this notebook. So this is just importing some the GWST module in Astro Query. I will not enter this because this is not needed for the demo. Then here I'm just setting some coordinates. Maybe I'll make this a bit larger. Oops, sorry. Oops, ugly error. Yeah, this is not needed. Okay, so I'm setting some coordinates and some radius because I'm going to do a concert. This Astro Query module for James Webb has some help in it to teach the users how to take advantage of this module. This module has only just a few Python routines, just to keep it simple, but still really powerful methods. So now I was just querying, so I'm querying the actual James Webb archive because the metadata is public. What is not public is the data itself, but metadata is public. At the same time, we also have metadata for the future observations, for the observations that have been approved for the cycle 1. And this is also public, so there is no problem by showing this. So here's just like some example with really lots of information. You can add some additional filtering in these queries to the archive by adding the level of processing, the so-called calibration level of the files, and the amount of information that you want to show. This is in the data model for Hubble and for James Webb. There is quite a lot of columns, and so this is what it comes out of this query to the archive. Now let me show you some additional information, just some observation IDs and product types and the calibration level. This means that these are future planned observations, and this is the instrument that will be used for this observation. Then we have methods to get the list of products that are available from the archive. We also have methods to actually, once you know what you want, to download it if you have the necessary permissions. Then we also have another method that is called get related observations, just because it is possible to produce higher level products out of different combinations of lower level products. So this will tell you who are the parents and who are the children of the various products. Now let me do another example. This is because I need it for something else in a minute. So essentially, we have this Astro Query module that will allow users to explore and download data from the archive once it's public, or to download it from the MAST archive via the EGWST archive if they have the necessary credentials, and this is possible. And also the other thing that we have integrated in our data labs in ESA Datalabs is ESA Sky, which is the Jupyter Lab widget for ESA Sky. And in this case, this is, if you haven't seen ESA Sky, which I'm sure you have, because it's such a great tool that we have developed here at ESAC. Let me just put this here on the side. If I can, just for the purpose of this demo, it will be nicer. Okay, let me move this a bit. So now with the data that I was collecting before, now what I want to do is to overlay the metadata that came out from those queries into ESA Sky, and this can be done with this Python module. Here you can see for those media observations, now we have here the footprints projected onto the sky with ESA Sky, which is great. We also have in ESA Sky, and also accessible via ESA Sky, the James Webb planning tool that can be accessed also via the notebook. And here I want to open some, to project in the sky some media aperture. I'm typing it wrong on purpose, so it's giving me the actual available apertures. Now I'm telling it to project the so-called media full aperture. And if you see here, it did overlay it did project onto ESA Sky not only MIDI, but also the rest of the JWST focal plane, which is great when you are planning observations. Similarly for the NIRCam focal plane, which is this one. And yeah, and you can just zoom in and zoom out and do lots of really cool things with ESA Sky. Okay, so this is on the ESA Sky side. I was also mentioning before that in addition to the notebook that we have to teach users how to query data in James Webb and explore it and analyze it in Datalabs, we have these other examples that we haven't. Well, we are not the owners of these products. These are fully developed in STSCI, but we think it's a great product, and we just keep it here, a copy here, and we maintain it up to date. For example, here what I have is one of these examples of how to do integral field unit modeling. And what we did is install in Datalabs some of the basic packages that are needed to analyze this data. But many of these notebooks, they require additional software, but it is possible to install it locally in your user account, but you just need to follow some installation instructions. But what we installed here is the so-called JWs, which is this visualization package developed in Baltimore in STSCI for James Webb. And we install it in Datalabs so that the users who want to take advantage of these example notebooks, they can also do it in Datalabs, just getting access to the data here in Europe. Okay, so this is on the notebook side. I'm not going to run an example of how to run the actual processing pipeline, but this will be done in the other example that I'm going to show. So one other thing that we have here in ESA Datalabs, in the James Webb containers, is the calibration pipeline. But then on top of this, what we have is this pipeline management system to use this software and reprocess any James Webb data. And this is just a diagram that I'm taking from the STSCI website that you can see that there are these various steps in the analysis, in the processing of the James Webb data. And what we have implemented, and I will be showing now is these two steps, detector 1 and image 2. And each one of those steps has many sub-steps. And the good thing about this pipeline system is that you can define which of these sub-steps you want to do. And as I was mentioning before, since these pipelines, they have a versioning system, you have a very good control of the version of the software that you are using and of every single step that you executed during the processing. Similarly for the image 2, it also has like different sub-steps depending on which of the instruments you are analyzing. So what I'm going to show here is I'm going to show it in two different ways. One way of showing this is when you come to this, this is our development environment, the same one that Vicente was showing, so hopefully it will work for me out of the box. So what I'm going to show here first is the pipeline editor, but in this case for the James Webb, for a James Webb real case. So this is the So this is the James Webb pipeline in the sense of the two processing steps that I was mentioning before. This is detector 1 and image 2. So here you can very easily define what is the input file for your processing step, and then the output of this step 1 is then used as an input for the second step. So it's always very clear what is the input and the output. Then we have the calibration files hosted here at ESA. So this gives us a lot of, well, this is very convenient. And then you can define the location of these files. But the thing is that if you are part of the instrument team, or if you are just like, for some reason, you want to go beyond the standard processing of the Space Telescope processing pipeline, and then you want to override some of the defaults on the software, then we also give the users the possibility to override the calibration files to provide modified versions of the calibration files. And this is done by this override inputs for the step 1 and also for the step 2. So this is really powerful. And then when you want to execute this, just let me show you again that these 2 steps, they can, each one of them has its own well-defined inputs and outputs. Same for so this was for image 2. Somewhere here I have the detector 1, here it is, with its own diagram, and also well-defined inputs and all these overrides if they are needed. And then if I want to actually execute this pipeline, I can do it in 2 ways, either using this pipeline editor graphical user interface or via a notebook. So if we want to do this from here, this is very similar to what Vicente was showing. So let me see if I see how to, sorry, it's here, launch a new pipeline. Then I want to launch the James Webb pipeline. So here I define, okay, what is my input file? So then I provide some example file. This is some simulated file that we've been using for our demos. Then I provide the location of where are the calibration files located. And then I'm not going to set any of the override parameters. Then I just skip over this. Maybe I define my output directory, and I just launch the pipeline. And then you see it's now it's going to be, in principle, everything looks right. You see it's started to execute. This is a 2-step process. So it will first, now it's starting the first one. It will eventually finish and then go into the second one. And when it finishes, it will turn green like this ones. And the really nice thing about this work is that you can also do this from a notebook, which is also, very convenient for many reasons. And here is just, I have also an example of how to launch one of these examples. In this case, from this notebook. Let me just let me make sure that I'm mounting the necessary volume. Yes, and then I need to update this here, I think. Let me just double check that the folder is okay. Yes, it's capital letters. So now I'm just defining what is the input file and the location of the calibration files. And since I'm not setting any overrides, I will just run it as it is now. And then I'm going to, okay, so you see the pipeline has been executed with this ID number. And then I can get some status here. And now if I go back to the user interface, I should see, oh, there it is. You see, this is the pipeline that I launched like 1 minute and 24 seconds ago, and this is the one I just launched from the Jupyter notebook, and this is really powerful because you have when you go to the actual pipeline, you can get a lot of you can control the versions. Here you can see, like, for these dependencies, for these 2 steps of the detector 1 step and the image 2 steps of the pipeline, here is very clearly stated which version of the software has been used. And if I wanted to update this, either the workflow itself or the software that is running behind, there are mechanisms to do this here and to keep track of this so that it is all really well under control and versioning. And And I think this is very much what I wanted to say. This takes 23 minutes to run, so so I think we believe me, it will eventually finish, and then the output of this the output of this pipeline is a calibrated image that I could display with Aladdin very easily. And in fact, in ESA Datalabs, we have not only Aladdin, but we have other feeds viewers as well, and so to facilitate the people's work. So I think I will stop here this part of the demo.
Thank you very much, Marcos and Vicente. It was a very, very nice demo, and I think we all learned a lot. I'm going to see if in Slack there are some questions, and I think there are. So Peter Cicluna is asking, Vicente, is data in the workspace shareable or exclusive to the user?
Yeah, very good question. Can you hear me, right? Yeah, I'm not.
We can hear you, yeah.
Yeah, actually, this is a feature that we were discussing a few minutes ago in the ESA Datalabs user group, which will become available in our next release. We introduced the concept of teams. And as a team, you have a workspace, which is the team workspace. So for example, we have seen kind of, Marcos didn't go into the details, but JWST, for example, has a team workspace. And the team workspace contains all the notebooks and all the data that is shared across the team. So there's a team workspace manager who can add and remove users from that workspace. So that if you are in the JWST workspace, you can see what the others are doing, generating, or sharing in the team workspace. So yes, it is possible. It's just
very nice.
Part of the current operation. Yeah.
Okay, thank you very much. There are more questions. From Francisco Montenegro, Vicente Navarro, this looks an awesome approach. Do you have an estimate about the number of users that may use ESA Datalabs? How many more resources does ESA need to compared to the more classical archival approach, where users just access and download the data?
Very good question as well. And very interesting. And this is the question that we are wondering every day. How many are we going to have? What I can tell you is that right now I don't know whether you could see before when I was sharing my screen, Grafana, which is the monitoring tool that we have for ESA Datalabs, which monitors the current status of our cluster. I'm looking at it right now, and I can tell you that we are running like 161 Datalabs concurrently at this moment, with 61 active users right now, despite being in private beta. So this is, we have this infrastructure monitoring. And when we open, I mean, we have as you could see, you can go and register for the private beta so that you are notified when we go public. And we have around between 100, 200 users already in the waiting list in order to access the system. What the utilization of the system is going to be is difficult to assess. We have data that are heavier than others. For example, the JWST1 consumes 30 gigabits of memory when you launch it, or can consume up to 30 gigabits of memory. But this data lab is restricted to the JWST users. There are typical ones are limited to 8 gigabits or something like that. So that's the reason why I was mentioning in my initial slide that we are working in connecting ESA Datalabs to other computing infrastructure platforms. Why? Because the idea is that we are going to provide resources to our users up to a certain limit. Right now, we are thinking between 1 data lab to 5 data labs concurrently. And then if you are a user with an account in Amazon, you can add your credentials to ESA Datalabs, and then ESA Datalabs can spawn the execution of your data lab to Amazon. We are in conversations with Amazon and with other clouds, Google, to replicate our cluster in Amazon. And if you have an account there, the disadvantage in this case is that it won't be for free, because in that moment you will connect to your Amazon instance and you will be paying for that. ESA will pay up to a certain level. We don't know what the level will be, because it will depend on the interest that the platform will raise in the community, and the support that ESA will provide will also depend on this. So this is something that we are evaluating continuously, and that will be reassessed as we get users.
And probably when JWST starts generating more and more data, that will also increase the users a lot.
Yeah, pretty sure.
Okay, thank you for that answer. Janet Evans is asking, how long have folks at ESA been working on ESA Datalabs, and how many people, scientists, developers are involved in the project?
Another very good question. As I mentioned, the inception of the idea was 2017. And we've been working on what you have seen so far. We've been working with 3 parallel teams. So SciAps, Pipeline, and Core are 3 industrial teams working in parallel, the 3 of them, for around 2.5 years now in implementation time. On the ESA side, there's a users group with more than 50 people, which are contributing with ideas about how the platform should work. And inside this beyond the users group, there's the core team. Marcos is one of the members of the core ESA Datalabs development and coordination team. He's more than just a user. He's contributing very actively with ideas and with validation and testing and extensions. And in that core team, there's 5 persons, more or less.
Okay, thank you. I thought there was a question in the chat as well. So please post questions in Slack, because then we can keep them for the future. But Pratik Karmak is asking to Vicente, can we get specific data for my interest, like the photometry or their CCD images in specific filters for safe eats from the ESA Datalab? If yes, how will I proceed? So I think specific images and specific filters to request that. I don't know if that question is clear.
If I understand it well, I think that Marcos has shown a way through ESA Sky. Marcos, correct me if I'm wrong. So you can actually download the data through the ESA Sky, but maybe Marcos, you want to elaborate on that.
Yes, so I mean, if it is some data that can be accessed via ESA Sky and independently of where this data is coming from, it could be an ESA mission, it could be an NASA, JAXA, or any other ground-based observatory. If you can access it via ESA Sky, you can already get it in Datalabs using ESA Sky, as I was doing before. If it is data from an ESA mission, the public data from ESA missions will be slowly become available, well, slowly or fast. It will become available directly through the platform, and it will be accessible to the users. Of course, depending on the mission, it will have its own formats and difficulties. So the access will be done via some maybe query modules, or just like you just go to a directory and get it all. But the data from ESA missions will also be available at ESA Datalabs at some point.
Very nice, thank you. Another question appeared for Vicente. Oh, okay, that was the question that Pradeep was asking. So I think we answered that. I think then we have had all the questions that are in Slack. Then we're a bit ahead of schedule, but that's not a problem. Then we have a slightly longer break. Thank you very much, Vicente and Marcos, for this very, very nice overview. I think, yeah, we learned a lot in this last hour. We come back in 33 minutes, and yeah, have a nice break, everyone, and see you later.
Thank you very much. Have a nice day.